Good day, Bayaw. For today's video, we will be solving another problem from the book of Thermodynamics by Single, Chapter 9, Heat Transfer Steady State and Transient Conduction. A hollow spherical iron container shown in figure below with outer diameter of 20 centimeters and thickness of 0.4 centimeter is filled with iced water at 0 degrees Celsius. If the outer surface temperature is 5 degrees Celsius, determine the approximate rate of heat loss from the sphere in kilowatts and the rate of mass per unit time at which ice melts in the container. Thermal conductivity of iron is K is equal to 80.2 watts per meter degrees Celsius, and the heat from the fusion of water is 333.7 kilojoules per kilogram. We will be identifying the given first. We have here the diameter of the spherical container that is 20 centimeters, its length that is 0.0 centimeters, the temperature 1 that is 0 degrees Celsius, temperature 2 5 degrees Celsius, the HIF that is equal to 333.7 kilojoules per kilogram, and the thermal conductivity that is equal to 80.2 watts per meter degrees Celsius. We will be finding the heat per unit time and the mass per unit time of the said container. Here is the solution. We have here the equation of the heat conduction per unit time that is equal to the thermal conductivity times the area times the change of temperature over each length. So before that, we will be solving for our area. We have here the area that is equal to pi times the diameter squared. So we have here the 0.2, the diameter of the spherical container squared, and we have here the area that is 0.126 meters squared. And since we have our area now, we'll be plugging in the values in our equation. We have here the 80.2 watts per meter degrees Celsius times 0.126 meters squared times 5 minus 0 degrees Celsius over 0.4 times 10 raised to negative 2 meters. We have here the heat per unit time of the conduction that is equal to 12,632 watts. Lastly, we'll be solving for our mass of the ice per unit time that is equal to the heat of the conduction per unit time over the HIF, or the heat from the fusion of water. So we'll be substituting the values. We have here the 12,632 watts over 333.7 kilojoules per kilogram. And now we have here our mass of the ice per unit time that is equal to 0.038 kilograms per second. And that is the final answer.